Hi guys, thank you for joining me again. If it's your first time, please subscribe and check out some of the other videos. Today, as you can hear, I need to fix some crackly pots. If you haven't already, check out the previous video, which is a quick fix video. It may save you some time and money. So, today I'm going to show you how to identify a like-for-like replacement, and in part 2 I'll be soldering them in and finishing the job. So we need to find out the following. We need to get the resistance in ohms, the taper, whether it's logarithmic or linear, and the pot dimensions. We need to know the shaft length and the diameter and the body diameter. So let's look at the value. So on the back of this one, it's got some numbers there. Letter B, 470K. So that's 470,000 ohms. The B I'll come to in a minute. So that's 470,000, 470K. This one doesn't have it on there, but it has it on the side. 22,000 ohms. So that's the ohm sign, omega. 22K, 22,000. That one is written on the front. 1 meg. So that's 1 mega ohms. This one's 1K, 1,000. And the one here, 250,000, 250K ohms. And the next thing we want to do is look at whether it's logarithmic or linear. So these don't affect the value, but it affects the way it behaves when it rotates round. And on the modern ones, you should see a letter. And if it's A, it's going to be logarithmic, or sometimes that's called audio taper. And if it's B, what one would be on it? There we go. B is linear. So this one is a linear taper, 470,000 ohms. So this one actually has lin, L-I-N, so linear, written on it, although it does have A there, which suggests it could have been logarithmic. But it says lin, so imagine this is an older one. And sometimes in the older ones you'll see an A for linear. And this is 1K. And then this one, again, LN, so linear. But when you're buying the modern replacement, you'll probably see A for logarithmic or B for linear. You need to determine the actual physical size of them as well. So you can see here you've got a much smaller one here and a larger one here. If you get the same value, it won't affect how it operates, but what you've got to look at is, will it fit in your base? Now in a passive base, there's normally a lot more room in the cavity, and you find the larger ones. In some of the active bases, where it's very tight, and if it's on a circuit board, you'll probably find the smaller one. The next thing you look at is the diameters of the shaft. So you've got two diameters here. You've got the one with the thread on, so that's bit fits through the hole. You need to see if that's going to fit. And then you've got shaft diameter as well, which is slightly different. That's about the same on that one. But on that one, that shaft diameter is a little bit smaller than that. So you need to get the one that's obviously going to be the right size. So the length of it, quite often if you're going through the wood on the base from behind and it's not on a scratch plate, then you're going to need longer thread here to get through. If it's on a scratch plate, you're probably going to get away with a smaller thread because you've got a much thinner wall to go through. So you can measure them with calipers if you've got calipers, or you can try it with a ruler. So this one's 7.91. And the thing that the knob goes on at the top is just under 6mm. Doesn't really matter if it's got a split top on it or whether it's got a straight shaft like this one. This one's really long with a straight shaft. You can cut these down when they're like this and just cut them off to length. Sometimes they're plastic, you can get metal ones. Again, you can cut that down to length, so that's not a critical thing. But the diameter is what you're looking for, whether your existing knob's going to fit on it and whether it's going to fit through the hole in your base already. So the first thing we'll look at is whether it's a linear pot. So in a linear pot, let's assume it's 500k ohms. So 500k at one end and 0 resistance at the other end. And if you measure that on a multimeter, that's what you would get. You get 0 and you get about 500k there. So if you put it in the middle, to mark up the middle there, and you read that off your multimeter, you'd get approximately half the value. So you get your 250k. So then if you were halfway in between them, so you're about 3/4, you'll be getting 375. And if you're about a quarter of the way round, you'd be getting 125. So there's that direct relationship between the percentage of where you're going in your circle when you've turned it round and how much resistance you're getting. So halfway would be 250k. So now let's look at a logarithmic one, or log or audio taper. So again, if we look at 500k, so it'll be 500k there, and it will be 0 there. So then if we mark our halfway point, this is where it gets very interesting, because what you would have is a value halfway that is not half of your 500k. So you may only be getting, say, 30k or something like that. Depends on the way the pot is set up. So you'll be going from here, you get about 30k, and then it ramps up drastically and increases until you get there. So what effect that might have, if you used it on a volume control, for example, it may have this effect, that your sound would be off here and you'll be turning up your volume and not much is happening, turning it up, not much is happening. Then you get to about halfway and then everything starts to happen. It suddenly gets louder and you don't have any fine control because it's all sort of in this last bit here. Now that might be what you want from a tone control. It may even be what you want from a volume control. It depends what the circuitry is doing. But probably your volume control is going to be linear and the tone control is going to be logarithmic, but that's not necessarily the case, so don't use that as a hard and fast rule. But they just behave in different ways. So if you did interchange them, you may find it's better, or you may find it's worse, especially something like the volume, where you just get nothing for ages and then you get no control, and then all the last quarter turn is where all the volume comes in. So I need to replace these two. These are the ones that are causing the problems. I'm going to get you in closer and we'll have a look at what the value is and the size of it as well. So this one looks like it's 100k, and it looks like B on it as well. So 100k linear, probably. That's that one. So this one looks like it's another 100k, but it's A there. So we should be having a logarithmic one there. The pink lines are just idiot marks, so I remember which pots to replace. So let's get some other measurements here. The shaft looks like it's about 7.7, where the knob goes on, it's about 6. The overall length, just about 19, and the length of the thread that goes through just under 9. So those are the dimensions I'm going to be looking at. I'm going to measure the diameter of the body as well, and that's coming in about 17 millimeters. So now let's get online and try and find a pot that's as close to those dimensions as possible. Be sure to check out part 2 where I will be replacing the pots.